Okay, so we are getting ready for the final. The final has about 20 questions on it, and this is roughly the order. The first thing you'll be asked is to find the inverse. For me, that is problem number one. And so to find the inverse, you will do this using steps, and then we'll do this intuitively. So you have f of x equal to 7x minus 5 over 3. And the first step you do is you set y equal to 7x minus 5 divided by 3. So that's the first step. And then, let me make this thicker. Then you solve for x. When you solve for x, then that means you multiply both sides by 3. So you get 3y equals 7x minus 5. And then again, solving for x, you add 5 to both sides. You get 3y plus 5 is equal to 7x. And then you divide both sides by 7. You're solving for x still, so x equals 3y plus 5 over 7. And then the final thing you do is you switch the x and the y. And so you just literally switch the letters. So you get y equals 3x plus 5 over 7. And that, once it is in terms of x, is the inverse. 3x plus 5 over 7. That is the inverse. So the way that you can see this intuitively is that here, when you're doing the inverse, when you're looking for the inverse, you're doing the opposite operations in reverse order. So here, notice how we're dividing by 3. So you're going to be multiplying by 3. Here we're subtracting 5. Now you're going to be adding 5. And here you're multiplying by 7. You're going to end up dividing by 7. So it couldn't be any of these other ones because you're not doing the opposite operations that the current numbers are doing, right? Okay. Number 2, it says the value of a particular investment follows a pattern of exponential growth. In the year 2000, you invested in a money market account. The value of your investment T years after 2000 is given by the exponential growth model, 6300 e to the 0.069 t. By what percentage is the account increasing each year? And so that's simply the coefficient of the exponent. So that number is 0.069, and that means the answer is C. Okay, so I brought this problem up only because you'll be asked to write you'll be asked the opposite question. You'll be asked that if something increases by 2.3% and you start off with $1,000, then what is the exponential function associated with that for time t years? And so the answer to this one would be, well, the interest rate would be 0.023. And so the answer would be 1,000 e to the 0.023 t, right? So the interest rate just goes in the exponential power, and then you put a t right next to it. That's something to keep note of. And then the other thing we'll ask you to do is we'll ask you to set an exponential equal to a number and solve. And so here's the exponential model. They tell you how much is there in the beginning. That number there is a 0, which is this number. And so our function is a equals 700. So you put 700 pounds in something and it's decaying. And so it's going to be decreasing. and you want to know when it's equal to 139 pounds. And so that means you're solving for the time, which in this case is not written as t, but it is written as x, right? So you're solving for x there. And so we know how to do this. This is one of the last things we did. If you want to get x by itself, we're going to divide both sides by 700. And so e to the negative 0.01155x equals 139 over 700. And then we take the natural log on both sides. Apply the log. So then the natural log of e to the negative 0.01155x equals the natural log of 139 over 700. And then again, the natural log and e just cancel. And so it's negative 0.01155x equals the natural log of 139 over 700. And then you just divide by this super ugly number and put it in your calculator. And that'll be one of these numbers. Number 4, you're just plugging in what is f of x plus 2. That means you go to f, replace the x with an x plus 2. We're good at these two. X plus 2 squared plus 3. When you FOIL out x plus 2 times x plus 2, and then add 3, that will give you the answer. X times x is x squared, x times 2, x times x is x squared, x times 2 is 2x, 2 times x is another 2x, and then 2 times 2 is 4, and then you add another 3, x squared, 2x plus 2x is 4x, 4 plus 3 is 7. B. Number 5 asks about a line. You need 2 points for a line. You've been given 2 points. It's 1, negative 5. And the x-intercept is negative 1. And so they're trying to tell you that the other point is negative 1, comma 0. So when they tell you that the x-coordinate is negative 1, they're implicitly saying that the y-coordinate is 0. And so we know this now. We know that we're going to use y minus y1 equals m times x minus x1. That's the equation of a line. And so I'll use this one. So x1 is equal to 1, y1 is equal to negative 5. I could have used this one, but I chose the first pair. I need the slope. So the slope is the difference in the x coordinates, which would be the difference in the y coordinates, 0 minus negative 5, all divided by negative 1 minus 1, which is a positive 5 over a negative 2, which is negative 5 over 2. That is the slope. Plugging this into the formula is y minus y1, y minus negative 5 equals negative 5 over 2 times x minus the x1, which is that 1. And so simplify y plus 5 equals negative 5 over 2 times x minus 1. And if you write that on the test, that'll be perfect. And that one seems to fit C, right? So unless we saw, it's either C or D if you go ahead and solve all the way through. But if you write this on the test, that will be perfect. That's something that we did earlier. Number 6, we're doing the quadratic formula, or we're factoring. Either one works. And so here, first you bring everything on one side. You get 8x squared minus 55x minus 7 is equal to 0. And now we are about to factor. Again, you could use the quadratic equation. But here we see that we can factor. I put an 8x here and an x here, and then a 1 here and a 7 and a plus and a minus. And again, this is just in a lot of ways guesswork, and we can check to see if this is true, and if not, play around. 8x times 8x times x is 8x squared. 8x times minus 7 is minus 56x. 1 times x is a plus 1x, and 1 times minus 7 is minus 7. And negative 56 plus 1 is negative 55, and therefore this is correct. So all of that was just to check. So now you set them each equal to 0. 8x plus 1 equals 0, and then x minus 7 equals 0. And solving this one over here first, you get immediately that x is 7. Over here, 8x plus 1 equals 0. That means, subtracting 1 on both sides, that 8x is equal to negative 1, and dividing both sides by 8, you get that x is equal to negative 1 over 8. And the answer is B. So this problem was about factoring, and the one that you'll be given, you'll have to factor that for sure. Seven, we've done these, so it's 3, the natural log of 6x equals 27. We're solving for x. We're going to divide both sides by 3. The natural log of 6x equals 27 divided by 3 is 9. We just have to remember here that the base here is e, and so by definition, the base raised to the 9th power is equal to 6x. So e to the 9th power is equal to 6x, and we'll remember that we're solving for x. And so to get x by itself, we need to get rid of that 6. We're currently multiplying by 6, so to get 6 by itself, you divide by 6 on both sides. So x is equal to e to the 9th over 6, which is C. Eight is stuff we've been doing before about finding the vertex, the axis of symmetry. If you have x squared minus 2x minus 3. On the test, you'll be asked all sorts of things. So you might be asked, where's the vertex? So the vertex is at x equals negative b over 2a. A in this case is 1. B is negative 2, and C is negative 3. And in this case, that is negative 2 over 2 times 1, which is positive 2 over 2, which is 1. That's the x-coordinate of the vertex. To find the y-coordinate of the vertex, you plug in 1 into the function f of x, and you get 1 squared minus 2 times 1 minus 3, which is equal to 1 minus 2 minus 3, which is negative 4. The vertex is 1, negative 4. So you go to 1 and then down to negative 4. There is the x-coordinate of the vertex. I'm sorry, there's the vertex there. Okay. And so now, what's going to be asked is what are the x-intercepts? And so to find the x-intercepts, you set x squared minus 2x minus 3 equal to 0. So these are the x-intercepts. And so this requires us to factor. And so we have to be very used to factoring. I need the factors of -3 that add up to -2, and those factors are -3 and 1. And so this means x is 3 or x is -1. And so we would like to see you understanding that the graph hits at 3 and -1, like that. It has to open up. We also want to know the y-intercept. So the y-intercept, you set x equal to 0. And when you set x equals 0 into the original function, you get 0 squared minus 2 times 0 minus 3, which is -3. So it should hit the y-axis at -3. And those are going to be the things we look for when we're looking for the graph. That you know where it hits the x-axis, which was at, well, you know the vertex, which is 1, -4. So you know here. You know where it hits the x-axis, which is 3 and -1. So -1 and 3. And then it also hits the y-axis at -3. And all those three together gives you the parabola. For this question in general, we have that x is equal to the axis of symmetry is x equals 1. The domain is -infinity to infinity. The range is the lowest y value, which is the y coordinate of the vertex, -4 to infinity with a bracket around the -4. For this one, you need to do a transformation. Your original graph is e to the x, and you want to know what happens to e to the x minus 3. Well, e to the x looks like an exponential like that. And something like that. So it should just only go through 1. So it looks like that. And so this is just a graph. So that's the original e to the x. And so this is just a shift 3 units down. And in MyMathLab, it may be a shift of -3. But it's 3 units down. The domain is still the same as -infinity to infinity. And the range now, well, before it went from, the range was 0 to infinity. And now if you move everything down, the range goes from -3 to infinity. So the original range again was 0 to infinity, but then you're subtracting 3 off. You're subtracting 3 off, so it moves everything down 3 units. So that 0 goes down to -3. And if you take -3 off of infinity, it just stays infinity. Here we're asking about in behavior of x to the 4th. Oh, I think I skipped one. Yes, I did skip one. It is number 9. Okay. So number 9, we've done some inequalities, and we've also done some factor by grouping, and so we're going to just do them together. And so here, when you have x to the 4th, x to the 3rd plus 4x squared minus x minus 4 is greater than 0, then we're trying to test what values of x make this positive. And so we're going to factor first, and we notice that and we're going to factor by grouping. So both of these first two terms have an x squared in common. And if you factor it out, you're left with x plus 4. These second two terms have a -1 in common, and you factor that out, and you're left with an x plus 4. And then we notice that they both have an x plus 4 in common, and so we'll factor that out. We then factor by grouping. So this is really saying x plus 4 times x squared minus 1 is greater than 0. And then we'll factor one more time because we know that x squared minus 1 is really x squared minus 1 is x minus 1 times x plus 1. Okay, so given that, you then create a number line with a 1, a -4, a -1, and a 1. And the way that you get that is you take the opposite signs here. So you set each one of these equal to 0, and you get -4, -1, and 1 when you set them each equal to 0 and solve. And so now we just pick values in each one of these places. Here's place number 1, place number 2, place number 3, and place number 4. In each one of those intervals, we'll pick a value to plug in here to see whether you get a positive or a negative. And we're looking for positives because we want the value of the left-hand side to be bigger than 0. So we want to be positive. Okay, so over here, I'm going to pick a value less than -4, let's say -10. And then I go in here and I do -10 plus 4 is -6. -10 minus 1 is -11. And -10 plus 1 is -9. And a negative times a negative times a negative is a negative. I pick a value between -4 and -1, like for instance -3. Then -3 plus 4 is +1. -3 minus 1 is -4. -3 minus 1 is -4. -3 plus 1 is -2. And then a positive times a negative times a negative is a positive. I now need to pick a number between -1 and 1. I'll pick 0. 0 plus 4 is 4. 0 minus 1 is -1. 0 plus 1 is 1. 4 times -1 times 1 is a -4. And then finally, I'll pick a number bigger than 1, for instance, 10. 10 plus 4 is 14. 10 minus 1 is 9, a +9. And a 10 plus 1 is 11. All that stuff is positive. So bigger than 1 is a positive, right? So I'm looking again for the positives because I want things that are bigger than 0, and positive numbers are bigger than 0. So the answer to this question is that the x's that make this positive are all the x's between -4 and -1, and all the x's bigger than 1. I'm looking at the picture. -4 and 1 and bigger than 1. The answer for me is A, and it's written in interval notation as well. Okay. Number 11, it talks about end behavior. And so we said before, let's get this chart together. That if you look at the leading coefficient, the leading coefficient is going to have, the leading coefficient is where the highest power is. And so if n is positive, n is either going to be even or odd. And the coefficient A is either going to be positive or negative. And if A is positive and the coefficient is even, it rises left, right. If A is negative and the coefficient is even, it falls left and right. If A is positive and n is odd, it falls left and rises right. And if A is negative and n is odd, it rises left and falls right. So for us, our leading term is 1x to the fourth. Again, if there's nothing in front of the x to the fourth, that means there's a 1. And so a is 1, n is 4, and that fits into this category. A is 1 is positive, and n being 4 makes it even. And so the graph rises to the left and rises to the right. The answer is A. What are the intercepts? That means you need to take x to the fourth minus 36x squared, and you want to set it equal to 0. We'll do some factoring here. They both have x squared in common. So you take the x squared out. You're left with x squared minus 36 is equal to 0. And then you set each one, you can factor x squared minus 36. That's x minus 6 times x plus 6. And so this means after setting each one equal to 0, is equal to 0, and then x plus 6 is equal to 0. I'll write that down here. Solving each one of those, you get that 0, 6, and negative 6 are your answers, and you would separate them with a comma. Now it's time to talk about multiplicity. And so when we see that x squared equals 0, that means, well, first of all, going back, the fundamental theorem of algebra says that there are 4 answers. And there are supposed to be 4 answers, but for some reason we have 3 answers here. And that's because this 0 has repeated twice. And so there are your 4 answers. And so when we talk about multiplicity, we're talking about how often does an answer appear. Okay, and here is the rule. So the multiplicity of 0 is 2. 0 has multiplicity 2 because it appears twice, and it's because that was a 2. Multiplicity 2. 6 has multiplicity 1 because it appears only one time, and negative 6, it has multiplicity 1 because it appears only one time. So here's the rule. The rule is that when a solution has even multiplicity, that means it's going to hit the x-axis and turn back and turn around. Then it turns. Okay. And when it has odd multiplicity, like the 6 and the negative 6, they only appear once, and once it's odd, then it crosses through the x-axis. So crosses through when the multiplicity is odd. So for this particular problem, at which 0 does the graph of the function touch the x-axis and turn around? It would be at the 0 that has, it would be at the solution that has a multiplicity that is even, and that would be 0 because 0 appears 2 times and 2 is even. They may ask you about the multiplicity, whether it crosses through 6 or negative 6, and it would cross through the x-axis. The y-intercept, you plug in 0 into the function, and that will give you the y-intercept. So if you plugged in 0 here into f, you get 0 to the 4th minus 36 times 0 squared, and that is 0. You would just put 0 there. They won't ask you about even or odd on the test at all. And they won't ask you to find the graph. Vertical asymptotes. So I'm going to talk about both. I want to talk about vertical and horizontal asymptotes. So vertical asymptotes. We talked about this as well. You want to set the denominator equal to 0 here. So the denominators here are x and x plus 8. And then you want to just set that equal to 0 and solve. And so this means that either x is 0 or x plus 8 is equal to 0. And so that means that x equals 8 and x equals -8 are potential vertical asymptotes, as long as there's no canceling in the original function. And because x plus 3 can't cancel out x, and x plus 3 cannot cancel out x plus 8, that means that there are no holes at all, and that the vertical asymptotes are 0 and -8. So when you're looking for vertical asymptotes, you need to set the denominator equal to 0 and solve. And sometimes it won't be as nice as this one, where you might have to factor and set the denominator equal to 0, factor, and solve. If you want to define a horizontal asymptotes, so to do horizontal asymptotes, it's pretty straightforward. You need to look at the powers of the numerator versus the powers of the denominator. So for horizontal asymptote, the horizontal asymptote is also a line, but it's y equals horizontal asymptotes. And for this one, you notice that the power of x in the numerator is 1, and there are 2 x's being multiplied in the denominator, so the power in the denominator of h here is 2, and when the powers are higher, when the power in the numerator is higher, when the power in the denominator is higher, then the horizontal asymptote is y equals 0. And that would be a horizontal asymptote. We did not get a chance to talk about any of this stuff for 13, 14, and so forth. But it's pretty straightforward. I'm going to have it as extra credit. So if you want to solve this system, there's a way of solving the system without having to do anything with the letters necessarily, and you would have to use a matrix. And so what you would do is, actually in solving this, you would just be playing with the coefficients of the matrix. And so when they say what is the augmented matrix of this system of equations, then you're just going to use the coefficients. Now let's be clear, there are 3 equations here, and there are 3 letters, x, y, and z, and so in this system there's a unique x, y, and z that solve this system. So if I find the x, y, and z, I should be able to plug it in the first equation and get 2, plug x, y, z in the second equation and get 2, and plug x, y, and z into the third equation and get -9. Okay, so there's a process for solving that, and that process really just involves the coefficients. And so this first column represents all the coefficients of x. This second column represents all the coefficients of y, and this third column represents all the coefficients of z, reading downwards. And the third column, this bar signifies an equals, and the fourth column, represents everything on the right hand side of the equal sign. The answer to this question is 4, 9, 1. The coefficient of x here is 1. 1y, -9y, -9y, -2y, 7, -1, -5, and then 2 to -9, and that is it, right? And so this first equation, this first row here represents an equation, and it's 4x plus 1y plus 7z equals 2. Okay. And so you're only going to be asked one of these, but then I just want us to practice. This one is 1x minus 1y plus 16z equals 9. There are no x's, 0 x's in the second equation, plus 1y minus 12z equals negative 8. There are no x's plus no y's plus 1z equals 4. Ax minus 3y plus 6z equals negative 3. 4x minus 5y plus no z equals 1. And then 3x, there is no y, minus 6z equals negative 2. Here we're going to go backwards. Write the system of linear equations represented by the augmented matrix to the right. Use x, y, and z for the variables. The first one says that 3x, there is no y, plus 2z equals negative 13. The second equation, there is no x, 0x plus 1y minus 2z equals 12. And the last equation says that 2x plus 5y, there is no z, equals 3. For 17, we're doing parabola stuff. Here's the standard form of a parabola, a times x minus h squared plus k. And they gave us the vertex. We know that the vertex is hk. And they gave us h and k. So h is 7 and k is 8. And so what happened to f of x is that it becomes, and nothing happens to the a. The a is just 6 here because the original a was 6. And so the answer is 6 times x minus 7 squared plus 8. That's what happens when we move it by the vertex. And you do the same thing for number 18. We want to solve for x and get x by itself. And so as we solve we've solved these equations before, we know we have to multiply everything by the common denominator. And so the first thing we'll do is we'll simplify, and we notice that 19 is really 10 over 5 times x minus 1 plus 1 over 5 equals 2 over x minus 1. And so we notice that in the first denominator, they both have a 5 in common, and we factor it out. And so in solving these, what we want to do is get rid of the fractions. And so we end up multiplying by something that will cancel out. Well, we multiply something that cancels out all the denominators. And that means we need to multiply by a least common denominator. And that's a denominator that has all of the things in the denominators we currently see. And that term is 5 times x minus 1. Multiply everything times 5 times x minus 1. Okay. So when you do that, after this step, there should be no more denominators. And that's what happens here. So 5 times x minus 1 completely cancels with this 5 times x minus 1, leaving a 10, plus this 5 and that 5 cancels, and then this 1 multiplies the x minus 1, leaving an x minus 1. This x minus 1 cancels with this x minus 1. The 2 and the 5 multiply to give you 10. And then now we're ready to solve. After this step, there are no more denominators. X plus 9 equals 10. X is equal to 1. But that presents a problem because 1 was never a solution to this, right? So it says write the values that make the denominator 0. So when you take a denominator and you set it equal to 0 and solve, you get x minus 1 equals 0. And so x equals 1. And so this is a bad place We don't want those because it makes the denominator 0. And so we got that the solution is something that's bad, and so that means there is no solution. The answer is D, that x should not be 1, and that symbol there means that there is no solution. 20, we're solving systems of equations. We're going to solve it using the substitution method. X plus y equals 12, but I know that y equals x squared minus 12x plus 36. And so the substitution method says that, well, if I know what y is, and I know that y is this, then I'm going to replace this with what y is equal to, and then solve for x. And then once I have x, I can go back and get y. So if x plus y is equal to 12, and I know that y is x squared minus 12x plus 36, then I'm just going to write x plus x squared minus 12x plus 36 is equal to 12. I just completely replace the y with what it's equal to. Right? And then I'll simplify. So then x squared, and then x minus 12x is minus 11x plus 36 is equal to 12. And then I'll bring the 12 to the left-hand side with the intention of factoring. X squared minus 11x plus 24 is equal to 0. And now it's time to factor. The factors of 24 that add up to 11 are 8 and 3, and they both have to be negative. And so x is 8, or x is 3. And now I need to go back and find out the y coordinates. Now this is, you just have to be paying attention. Remember that x plus y equals 12. So they have to add up to 12. So if x is 8, then x plus y being equal to 12 forces y to be 4. So 1 point is 8, 4. And similarly, in the other case, when x is 3, then x plus y equals 12 means that y has to be 9. So the other point is 3, 9. D. #21, we're going to do something similar, but it's just a word problem. The Family Fine Arts Center charges $25 per adult ticket and $10 per senior citizen ticket for its performances. On the recent weekend evening, 557 people were paid, and they were either an adult or a senior citizen. The total receipts were $8,495. How many who paid were senior citizens? I may need my calculator for this. Okay. So what we'll do is we'll use x and y. So we'll let x be the adults, and we're going to let y be the senior citizens. And just like the previous problem, we're going to just write out two equations and use the substitution method. This one's actually going to be easier. From the sentences, we need two equations. So if x is the number of adults and y is the number of senior citizens, it says that there were 557 total people. So that the number of adults plus the number of senior citizens is 557. Now, there's some other equation involving $8,495, and so that's in dollars. And so how do you get dollars? Well, it was $25 for each adult and then $10 for the senior citizens. That gives you the $8,495. So $25 per adult plus $10 per senior citizen. So those are your two equations, and just like the previous problem, we're going to use the substitution method and say, hey, wait 1 second, this right here means subtracting x on both sides, that y is equal to 557 minus x. And then I'm going to take that and I'm going to plug that, I'm going to put that right there to get x by itself. 25x plus 10 times 557 minus x equals 84.95, and you just solve for x and it's over. Right? And once you get x, remember, we're looking for y. They wanted to know the number of senior citizens. So 25x plus 5570 minus 10x equals 8495. Combining like terms, 25x minus 10x is 15x. 15x plus 5570 equals 8495. And 15x, subtracting 5570 on both sides, looks like it's, I want to get the calculator out. Let's do that. $8,495 minus 5570 equals 2925, and now my intention is to divide that by 15. X is equal to, divided by 15, 195. Of course, that's going to be one of the answer choices to try and trick you. We were looking for the number of senior citizens, which we labeled as y, and so we have to remember that y is 557 minus x. Y is 557 minus x, and we just figured out what x is. It's 557 minus 195. X, I'm sorry, the number of senior citizens is 362. For us, that is B. '22. They're doing f of g of x. And that means wherever there's an x, you put g. And so f is 8 over x plus 2. And so now you're going to do 8 over g of x plus 2. So instead of having an x there for f, you put g there instead. And this is going to look nice and funky. This is 8 over, and now put g there. But g is 5 over 2x plus 2. Right, so now we have a fraction, 5 over 2x inside another fraction. And so nobody ever likes that. And so what they'll do is they'll multiply. They want to get rid of the fractions by multiplying the numerator by 2x, and then multiply the denominator by 2x. So they do this to get rid of this denominator in the fraction. To get rid of the fraction in the denominator, 8 times 2x is what the numerator becomes. It's 16x all over, and then you distribute this 2x times everything here. 2x times 5 over 2x is just 5 because the 2x's cancel, and 2x times 2 is 4x. That is putting one function inside the other. '23, we're just remembering log rules. We just have to remember for logs that division turns into subtraction, and all the powers come out in front, and that the square root is the 1/2 power. So this is really, the first thing you have to realize is that this is really log of 9 over x minus 1 to the 1/2 power. And if we remember from the last test that division turns into subtraction. So this is really log base 3 of 9 minus log base 3 of x minus 1 to the 1/2. And then we also remember that all powers come out in front. And so this 1/2 comes out in front. Of course, this doesn't look like any of the answer choices. And so we just have to remember that MyMathLab likes to simplify. Log base 3 of 9 is a very nice thing. The log is the power. So this is the power. This number is the power 3 needs to be raised to in order to get 9. That number is 2. This is 2 minus 1/2 log base 3 of x minus 1, because 3 to the second is 9. D. All right, that's the end. So that should get you where you need to be. And class tomorrow, feel free to ask for any clarifications. We'll be working on this for the rest of the week. I hope it was helpful, and I will talk to you in a few seconds if you're listening to this in class. Thanks.